See, the next topic is cone. See, it's a solid cone. How do you get this solid cone? It is generated by revolving the right angle triangle. Any one of the sides in the right angle triangle containing the 90 degree. That is here the base and the height with respect to h or with respect to r. Here I give the rotation with respect to h. So in that case, the h becomes height of the cone, then r becomes the radius of the cone. See, the lower part, the base part becomes the circle. If you give the rotation with respect to this perpendicular height in terms of h, we get the circle that radius is r. And this hypotenuse becomes the slant height. Now we'll see this relation between h, r and l. R is radius of the cone. H is height of the cone. And L is slant height of the cone. Slant height of the cone. So L is equal to, it is a right angle triangle. So the square of the hypotenuse, here the side opposite to 90 degrees L. Square of the hypotenuse is sum of the squares of the other two sides. So L, we get it as L equal to square root of h square plus r squared. So if I want h, that is equal to, you take this r squared to the other side, L square minus r squared. And r, if I need, that is take h square to the other side, L square minus h square. Now we will see the curved surface area of the cone. Curved surface area of the cone. See, let me directly write the formula. The derivation of this formula, just you can go through in the book. It is pi r into L square units. Pi r into L square units. R radius, L is slant height. Total surface area of the cone. Total surface area of the cone. With this curved surface area. Curved surface area means this cone shape here. Pi r L plus the base circle area pi r squared. Take pi as common, r as common. The remaining term is here L plus r. Pi r into L plus r square units. See, in the cylinder we have 2 pi RH. We don't get 2 here. Pi r, in the place of h I have L. Same thing here, 2 pi r h plus r. We don't have 2 here, pi r. In the place of L we have h. So you can have the connection and learn the formulas. Okay, using these formulas, let us see the problems. See, question example 7.5. It is in page 275. Page 275. The radius of a conical tent is 7 meter and the height is 24 meter. Calculate the length of the canvas used to make the tent if the width of the rectangular canvas is 4 meter. See, we have the canvas sheet here, just like cloth. With the cloth, we make the conical tent, cone-shaped tent. So, we make the tent only the curved surface area. See, not the bottom part. So, in that case, you have to find only the curved surface area of the cylinder. That is equal to the area of the canvas we need. The canvas sheet is actually, the width is same throughout the barrel. The length only will vary here. So it is a rectangle shape. So in that case, the width is given, breadth 4 meter. You have to find the length, how much meter we need to make the conical tent. So let me take the measurements. The radius of the conical tent, right, cone. The radius is given as 7 meter. All units are in meter. And the height is given here 24 meter. 24 meter. So here 3 units you have. Radius R, H is given. So one more unknown thing you have to find, L. The formula for finding L is H square plus R square. Square root of 24 square plus 7 square. So what is the value of 24 squared? 576 plus 7 squared is 49. You add these two values, you will get 625. Square root of 625 is 25 meter. So we got the slant height of the cone. So we need to find the curved surface area of the cone. Conical tent. The formula is pi RL. Square units. So pi is here 22 by 7 into here R is 7 into L, just now we have got 25. The 7 cancel, 22 into 25. So 550 meter square. So this is a curved surface area of this cone. This area is same as the area of the canvas. So area of the canvas is equal to curved surface area of the cone. Curved surface area of the cone. What is the area of the canvas? I said length into breadth. So this is, we got as 550. So the breadth of this canvas given for you, the width, that is 4 meter. So L only you have to find. L into 4 is equal to 550. So L is equal to 550 divided by 4. So 1 4s are 4, carry over 1. 3 4s are 12, carry over 3. 7 4s are 28. Remainder 4. Then put 0 dot and add 0, 40. Sorry, 20. Remainder 20. So remainder 2. 7 4s are 28. Remainder 2. Put dot and 0, 20. 5 4s are 20. Meter. Just meter, because this is the length of the canvas. So therefore the length of the canvas. The length of the canvas is equal to 137.5 meter. See next example on the same page, example 7.6. Same page you have, page 275. If the total surface area of a cone of radius 7 cm is 704 cm square, find its slant height. So this is the direct question here. The total surface area of a cone of radius is 7 cm. Total surface area is given. Total surface area is 704 centimeter square. See the units, it is in centimeter. Question is find the slant height. So in the total surface area or curved surface area, we have only R and L term only. No need to get the H. So total surface area formula is 2 pi R into L plus, sorry, no 2 here, pi R into L plus R. Pi R into L plus R is equal to 704 centimeter square. Pi is here 22 by 7. R is 7, L we have to find. R is 7, 704. So you cannot add L and 7, keep as it is here on the left side, L plus 7, 704. 22 by 7 is 7 by 22. Into 7 goes to the other side, 1 by 7. So I can cancel this 7 and the 7. So 22 in 11 it goes 2 times. In 11, 76 6 are, 6 11s are 66, remainder 4, 4. Then again this cancel, 2 goes here 32 times. So 32, L plus 7 is equal to 32. So L is equal to 32 minus 7. 32 minus 7 is 25 centimeters square. So that's what you have to find. L, slant height of the cone is equal to 25 centimeter. See, exercise sum, fourth sum. A right angle triangle PQR, where Q is 90 degree, is rotated about QR and PQ. If QR is 16 centimeter and PR is 20 centimeter, compare the curved surface areas of the right circular cone so formed by the triangle. See, first thing is a right angle triangle PQR. Angle Q is 90 degree. So I have drawn that right angle triangle. This right angle is at the vertex Q, PQR. See, they are given the measurements also. QR is here, base is 16 centimeter. And PR, it is a hypotenuse opposite to 90 degree, 20 centimeter. So only two measurements are given. One more measurement is missing here. PQ, one of the sides, adjacent sides of this right angle. So first you find that in triangle PQR, angle Q is 90 degree. 90 degree. So according to Pythagoras theorem, the square of the hypotenuse side PR squared is equal to sum of the squares of the other two sides, PQ square plus QR squared. PR squared is 20 squared and PQ squared you have to find that, plus QR squared is 16 square. 400 is equal to PQ squared plus 16 squared, 256. You bring this 256 to the left side. 400 minus 256 is equal to PQ squared. So PQ squared is equal to 400 minus 256, 144. So PQ is equal to square root of 144, that is 12 centimeter. So we have got the other side also, PQ 12 centimeter. Now look at the next line. Compare the curved surface areas of the right circular cones formed by the triangle. See, the rotation is given, is rotated about QR and PQ. The rotation is given with respect to QR and also with respect to PQ, both the sides. Both the sides are adjacent sides of the right triangle. So let me take two cases. The first case, case 1, I am giving the rotation about the side PQ. We give the rotation about the side PQ. We rotate PQ. So in that case, 20 centimeter becomes the slant height, and then this base 16 centimeter QR will become the circle. So the radius is 16 centimeter. We give the rotation about this here 12 centimeter, no? So 12. This is 20. PQR. So this base 16 centimeter becomes the circle. So that is your radius 16. And then the slant height. So L is our 20 centimeter hypotenuse. So if we rotate, so you write this. If we rotate about PQ, about PQ. So our radius is 16 centimeter, that is base QR. QR is our base, 16 centimeter, and PR is our L. L is equal to 20 centimeter. You have to compare the curved surface area. So curved surface area equal to pi RL square units. Here you need not substitute for pi, just keep as it is. R is 16 and L is 20. So 0, 2 into 16, 320 pi square centimeter. So this case we give the rotation about the side PQ. Now give the rotation about the side QR. Rotate about case 2. Rotate about QR. So if you rotate about QR, PQ becomes the circle part. So in that case, PQ is our R. R is equal to 12 centimeter. And then PR is same. Hypotenuse. PR is equal to L is equal to 20 centimeter. So what is the curved surface area? Curved surface area is equal to pi RL square units. Pi up as it is, then 12 into 20. So 0, 12 twos are 240 pi square centimeter. So let me mark this as answer 2 and this is answer 1. So you look at both the cases. Here, which number is greater? 320 pi. In the first case only we get the greater value. That is, in the first case we give the rotation about PQ. So therefore, so just write from 1 and 2. 1 and 2. This first answer 320 pi is greater than 240 pi. This is answer 1 and this is answer 2. So the answer 1 we give rotating about PQ is greater than rotating about QR. So that is the question they ask you. Compare the curved surface area of the circular cone so formed in the triangle. So this is the answer. Rotating about PQ is greater than rotating about QR. Thank you.